So we have here a list of powers, some powers of 2s, some powers of 3s, some powers of 4, and some powers of 5. Notice that the exponents are 4, 3, 2, 1, 0, negative 1, negative 2, negative 3. So we can say that the exponents go down by 1. We can easily find the powers when the exponents are positive, but we're not very familiar when the exponents are 0, as in here, and when the exponents are negatives. So our goal is to find out a way to determine the value of 2 to the 0, 3 to the 0, 4 to the 0, and 5 to the 0, and to evaluate exponents that are negative. So let's begin. 2 to the 4th, we know that's going to be 2 times 2 times 2 times 2, which is 16. And 2 to the 3rd is 8. And we know that 2 to the 2nd is 4. And 2 to the 1st is 2. Now, what is 2 to the 0? We're stuck a little bit. So let's go back to what we have here so far. So how is 8 related to 16? I noticed that 8 is half of 16. And then if I go down to the next one, I have here 4. 2 to the 2nd is 4. And I noticed that 4 is half of 8. And the next one is 2. And 2 is half of 4. So I noticed that there's a pattern because it's always half of the previous number. So if I actually go here and find 2 to the 5th, is 16 half of that number? Well, let's find out. 2 to the 5th is 2 times 2 times 2 times 2 times 2, which gives me 32. And 16 is indeed half of 32. So I think the pattern continues. And so if I want to find 2 to the 0, I'm going to use this idea here. I'll just take half of 2. And half of 2 is 1. So it tells me that, 2 to the 0 is equal to 1. Now, if I want to find 2 to the negative 1, then I'll just continue the pattern. I'm going to say that it's going to be half of 1. And 1 half of 1 is 1 half. And 2 to the negative 2 will be 1 half of 1 half, which is going to be 1 over 4. And 1 over 4 is the same as 2 squared. And if I want 2 to the negative 3, then that's just going to be half of 1/4. And half of 1/4 is 1/8. And 1/8 could be expressed as 1 over 2 to the 3rd. That was quick. So now let's evaluate the powers of 3's here. So 3 times 3 times 3 times 3 is 81. 3 times 3 times 3 is 27. Now, how is 27 related to 81? I noticed that if I divide 81 by 3, I'm going to get 27. So that means 27 is 1/3 of 81. Now, what is 3 squared? 3 squared is 9. And I noticed that 9 is 1/3 of 27. And 3 to the 1st is 3, which is 1/3 of 9. So if I continue the pattern for 3 to the 0, even if I'm not quite sure what it is, I know it's going to be 1/3 of 3, and that's going to give me 1. And therefore, 3 to the negative 1 is 1/3 of 1, which is going to give me 1/3, or 1 over 3 to the 1st. And 3 to the negative 2 will be 1/3 of 1/3, which is going to be 1 over 9, and 9 is 3 squared. So 1 over 3 squared. And so we'll have here 1/3 of 1/9, which is 1 over 27, but 27 could be written as 3 to the 3rd. So 3 to the negative 3 is 1 over 3 to the 3rd. Do we notice something here? Okay, so let's go to the powers of 4. 4 to the 4th is 16 times 16. That's going to be 256. You can check with your calculators if you want. 4 to the 3rd is 64. Now, how are these two related? It's not quite obvious, but you can think of having 4 4s in the 256 and only 3 4s. So 1 4 was taken out. So you divided by 4. So this is 1/4 of 256. I'm going to think of this as 1/4 of 256, which you can check with your calculator. So 4 squared is 16, and 16 is 1/4 of 64. And 4 to the 1st is 4, which is 1/4 of 16. So even if I'm not quite sure what 4 to the 0 is, I will think of it as 1/4 of 4, which gives me 1. And so this is going to be 1/4 of 1, so 1 over 4. And this is 1/4 of 1/4, so 1 over 16, or 1 over 4 squared. And then this is going to be 1/4 of 1 over 16, which is 1 over 64, and 64 is 4 cubed. Do we see a pattern? So we notice that if we have something like, if A is the base and we raise it to the 0, what do we get when we raise something to the 0? So we have here 2 to the 0 is 1, 3 to the 0 is 1, 4 to the 0 is 1. What do we think about 5 to the 0? I think it's also going to be 1. So we can have here A to the 0 equals 1. But there's a restriction to this. We say that 0 to the 0 cannot equal to 1. Although some mathematicians want to think of 0 to the 0 as equal to 1. Okay, we call it undefined. So A to the 0 is equal to 1 whenever A is not equal to 0. So A is not equal to 0. And we notice that if you have A as the base and we have an exponent that is negative, so let's say negative 1, then we know that this is going to be 1 over A. And so if we have here A to the negative n, then this is going to be 1 over A to the n. Now, we always want to have our exponents in a positive form. If the exponent is negative, we convert it to positives. Okay, there you go. So now we have seen how we can express or evaluate bases with 0 exponents and negative exponents.